Hello and welcome to Planting the Seed, our short series of behind the scenes and extra content episodes to accompany our new audio drama Seeds, which is inspired by the amazing true story of the world's first seed bank. My name is Nicholas Pitt, the artistic director of No Stone Theatre who made the series, and today I will be talking with Dr John Dickie of Kew Gardens Millennium Seed Bank, who we were lucky enough helped us with our research for the show. I will let John explain in more detail what happens there, but to give you an idea of its scale, its vault contains such an array of seed samples from all over the world, it is technically the most biodiverse location on planet Earth. I think it would be really useful if you just want to kick us off by maybe just explaining who you are, what you do, and a bit about where it is that you work.
Okay, I'm John Dickie. I'm head of seed and laboratory-based collections at the Royal Botanic Gardens, Kew. I'm actually based most of the time down at the Millennium Seed Bank, where my team there, the seed collections group, look after all the seed collections in the Millennium Seed Bank from the time they arrive through the door. Another group arranges the international partnerships that lead to those seed collections arriving with us. But from the time they enter the Millennium Seed Bank building till the time a sample leaves eventually for use, they do everything to the collections. So seed banking comes from crop seed banking, which was set up sort of around the time of the Green Revolution, when the plant breeders realized that in producing these high yielding but genetically homogeneous new varieties, they stood the chance of losing many of the old varieties, maybe the land races and even crop wild relatives that could provide them with a range of genetic diversity, which would allow those crops or crop groups going forward to have resilience bred into them. If a new disease arises, then the sort of monogenetic crop could easily succumb to it with no resilience whatsoever, and no chance for fighting back. So if these old varieties and their diversity were being lost, what they relied on was the fact that it was known that you can store seeds of many species for long periods if you dry them and cool them. At one level, it's straightforward food technology. So along with the international plant breeding institutes, they set up a network of gene banks. And Botanic Gardens saw the opportunity of using this same technology to um, to provide a backup ex situ for particularly threatened, possibly useful wild plants, non-domesticated use, but nevertheless useful, and threatened species in seed banks, and very cost effectively. So that's what we're doing. We're a conservation operation, conserving wild species now in the Millennium Seed Bank partnership, this global network. All over the world, countries join in under the terms of the Convention on Biodiversity to duplicate their ex situ seed collections at the Millennium Seed Bank for security going forward. But it's not only a Noah's Ark, if you like, of wild species. We actually expect those collections to be used in the more immediate term. And so we're sending out collections where we're allowed to, under the terms of the agreements we have with our partner countries and institutes. We're sending out rather over 2,000 collections every year to researchers, plant breeders, as long as they're state funded. We under the terms of the Convention on Biodiversity, non-commercialization, we don't directly deal with commercial companies, but a lot of initial plant breeding for the kind of resilience traits I was talking about, they're publicly funded anyway. And so we're fully compliant with the CBD and the Goya protocol. We've got seeds in the collection from around about 190 countries on Earth.
So what is a typical journey for a seed that arrives at the Millennium Seed Bank?
Well, members of my team will unpack it, and they'll pass the data to a couple of people in my team who look after the database. So it can then be accessioned. So everything that we know about that collection, its presumed name and eventually its confirmed name, um, where it was collected, who collected it, any other information about the site, all that information is entered onto our database. The collections are no use if they don't have a proper verified name and some what we call primary data about the collection site, where it was, country, locality, date of collection, um, as much as we can, an estimate of the size of the population of plants it was collected from, the number of plants within that population that we actually made collections from, etc., etc. So all that information is goes on the accession. Then the seeds themselves, once unpacked, will be taken as quickly as possible to a dry room because, as I said earlier, um, it's drying and then freezing that extends the storage life of what we call these orthodox seeds. Um, so we need to dry as quickly as possible to try and minimize, to stabilize any ongoing loss of viability that might be going on uh, from the point of collection or dispersal from the mother plant to its arrival at Wakehurst. We then, once they've been dried for a minimum of a month, not only does that stabilize any ongoing decline in viability, um, it makes any covering structures which are superfluous, may harbor unwanted pathogens, etc. And we go through a very time-consuming cleaning process. So, if you like, we separate the wheat from the chaff. The wheat is then X-rayed to check if it actually contains, if the seeds actually, it's a small sample. I mean, we don't put X-rayed seeds into the collection, so it's a kind of destructive sampling that it's soft X-ray, same as the dentist would use on your teeth. We don't want to risk any genetic damage, so we take a small sample and we X-ray to find out if there is a fully developed intact embryo inside, and also to reveal whether there are any insect larvae in the seeds. You can often see when you clean seeds the emergence holes left by insect larvae because many insects do have part of their life cycle. They lay their eggs in the soft developing seeds or fruits, and then the larva that hatches can consume the inside of the seed, and of course, by weight, you can't tell the difference because it's just animal matter rather than plant matter that the larva has consumed, and has not yet emerged. So we're looking for infestation by insects. So we get a couple of things from the X-ray, and of course, by the by, from the X-raying, we get a record of lots of internal morphology of species that have never been described before. So we get other information as well. During the cleaning process, it might have picked up a little bit of moisture from the air because seeds are hygroscopic. So we need to re-dry, and then we seal them in airtight containers, and they go into the -20. A fairly standard deep freeze technology, the same as would be used for keeping meat or butter in that kind of thing. They are stored in the main vault. They're in the vault it's largely underneath the public area. So in the public space between the two wings of the building is where the vault is. So the public walk right over it. It's not possible under most circumstances for people to actually visit the vault unless we have open days, science festivals, that kind of thing. It does happen, but on a day to day, we couldn't keep up with the demand. We've got getting on for 42,000 species, samples of 42,000 species down there. It's about 95,000 collections. So we're slightly more than 2 collections per species on average. Many of them, it's only 1 collection per species, and that that is something that we are actively pursuing now. The fact that within species there's a lot of genetic diversity that we perhaps need to consider. One area where I'll give you examples of two areas where we've been trying to get much more genetic representation of populations within species. One of them is a funded project that's now just about finished, which is called Adapting Agriculture to Climate Change. We've looked at the major crops of the earth and those which have seeds which can be stored in a seed bank. We've been targeting species across the range of all the wild relatives of those 29 different species, different domesticated crop species. We've been collecting all the cousins, if you like, because when it comes to breeding, the easiest crosses to make will always be of the closest wild relatives. So easy access to the traits in wild species of resistance to environmental change, disease resistance that you might want to get into a crop. And so we've got a much deeper representation in those crop wild relatives, subspecific genetic diversity, and even more intensively, we've recently been sampling the UK national tree seed flora, whereby we've collected seeds from all the UK native trees and some shrubby species totally across their range in the UK, in every one of the Forestry Commission's seed collection areas, and at each site we keep the collections from each mother tree separate. So we have a really intense genetic diversity sampling for the UK national tree flora.
You mentioned the phrase wild crop relatives, and that was something which Nikolai Vavilov was, I guess, was one of the main purporters of, and it was sort of founded as sort of founding principle of the seed bank that he made in St. Petersburg, which obviously the show that we've made is inspired by. What are the sort of challenges and difficulties and sort of big questions that having seed banks like the Millennium Seed Bank will help us be able to overcome?
Well, there are numerous. Again, and I should say that, of course, all that we do is really following what Vavilov did for those crop species that he worked on way back in the 1930s or even before. And so, all the crop seed banks follow that, and we've extended that into wild species. It's about opportunity, really. It's about once a species has gone, you're unlikely to recreate it, and all the opportunities that having that species for, in the broad sense, adaptation, resilience, bringing perhaps new species that people had not considered before because of the dominance. I mean, is it something like, I can't remember the statistic. Is it more? It's well more than half our calorific intake comes from just 3 crop species. If those go down, we're in deep trouble. We should never make any mistake that in situ conservation is always best. The ex situ operation that we carry out is first a backup, but secondly a means of making lots of species available for use very quickly and easily without having to recollect. So it actually supports conservation in getting. It's relatively easy to get local people in countries engaged with seed collection, seed conservation, also using seeds for restoration of degraded vegetation, degraded ecosystems, which themselves, they are, in general terms, the richer they are in species, the more resilient they are, more functional diversity, and it can be shown that degraded ecosystems ultimately impact on food security, through loss of pollinators, for instance, maybe preponderance of disease vectors, maybe even human diseases. The whole business of conservation and maintaining biodiversity has lots of impacts in the near future. I mean, the whole business of biodiversity loss, food security, climate change, water security, they're all elements of a perfect storm. And our efforts at biodiversity conservation is part of mitigating the thing that's facing the Earth right now.
An important reminder of the challenges we face, but also the solutions we can find when we work together. Thank you for listening to our first episode of Planting the Seed, and thank you, of course, to Dr John Dickie. I would urge you all to visit Kew Gardens Millennium Seed Bank in Wakehurst when it can reopen, obviously after the current restrictions due to COVID-19 are lifted. You can find all the relevant info on their website, kew.org/Wakehurst. And so you don't forget, you can listen to Seeds on our website, nostonetheatre.com, or on iTunes and Spotify. Please help us reach even more listeners by subscribing, sharing with your friends and family, and following us on social media at No Stone Theatre. Or you can join our mailing list where you can find more exclusive content like this interview, as well as more info about us and how we made the series. If you sign up before the 25th of November, you'll also be in with a chance of winning an A free print of our beautiful series artwork by Gemma Hattersley. Seeds is a No Stone Theatre production and was made possible with funding from Arts Council England.